Good day. Today we'll be looking at mutually exclusive and mutually inclusive events. The difference is one of the probabilities cannot occur simultaneously, that'd be exclusive. For mutually inclusive, they could occur at the same time. For the probability of A or B is simply the sum of the probabilities of the event since they cannot occur simultaneously. So let's look at number 1. When rolling a standard 6-sided die, what is the probability of either rolling a 2 or a 4? Well, what is the probability of rolling a 2? This is 1 out of 6 possible outcomes. The probability of rolling a 4. That is also 1 out of 6 possible outcomes. Therefore, the probability of rolling a 2 or a 4 is the sum of each probability, so 1/6 plus 1/6, 2/6, or 1/3 chance. So 33%. Let's look at number 4. If 2 fair coins are tossed, what is the probability that you can get either 2 heads or 1 tail? Well, in this scenario, I can flip the first coin and I can either get heads or I could get tails. That's the first coin. For my second coin, I could get heads or tails, for either the first outcome. So these are my 4 possible scenarios. What is the probability that you can either get 2 heads, 1 out of the 4 ways, or 1 tail? So I could get heads first and then a tail, or I could get tail first and then a head. That is 2 out of my 4 possible outcomes. So the probability of getting either 2 heads or 1 tail is the sum of these, which is 3/4, 75% chance. Go ahead and pause the video and try numbers 2 and 3. Okay, this is mutually exclusive. Let's look at inclusive. To do this, we're going to do the sum of the probabilities of each event minus the probability of their intersection, so where they would both happen at the same time. So, let's look at number 2. A card is drawn from a deck. Find the probability that the card is either a spade or black. All right, you need to know about a deck of cards. In a deck of cards, you have spades, you have clubs, you have diamonds, and you have hearts. There are 13 cards per suit, which is a total of 52 cards. Okay. Find the probability that the card is either a spade, so that is spades here, 13 out of 52 cards, or a black card. Well, my 2 black cards are spades and clubs, so that's 13 plus 13, 26 out of the 52. Now, where do they intersect? So how many spades are black? Well, that'd be 13 of them, so minus 13 over 52. This is 26 over 52. 50%. Okay, in this problem, including a spade did not matter because it would already be a black card. So there would be no difference than me asking you, a card is drawn from the deck, what is the probability of it being a black card? So it didn't change anything, but that will not always be the case. Let's look at number 3. A fair 6-sided die is rolled. What is the probability of rolling either an even number or a number greater than 3? So on my die, I have 1 through 6. Probability of an even number: 2, 4, 6, 3 over 6, or a number greater than 3. 4, 5, 6, which is 3 over 6. We're going to add these because of the OR statement. Now we need to subtract the intersection. Minus. How many numbers are even and greater than 3? That would be 4 and 6. So I'm going to minus 2 over 6. This is 4 over 6, or 2/3, approximately 67%. Basically, for this problem, what is the probability of rolling either an even number or a 5? That's what this one is saying. All right, go ahead and pause the video and try 1 and 4. Now here's your answer key. This is all that we have for you today, and I hope you have a great rest of your day.